Alright, so this video we're going to take a look at rules of logarithms. Alright, so the first ones we're going to look at are these inverse rules here, these two here. This says the log of a to the x with base a is equal to x. Now all this means is that if the base of the log and the base of the exponent, if they're the same, then your answer is your exponent here. That's all that means. And then this one, this right here, the log is in the exponent. So if the base here of the exponent and the base of the log are the same, if these two are the same, then your answer is what you're taking the log of. And so we have a couple of examples here. So we want to simplify this. So we can see this is equal to x squared. Now, how do we know that? Well, if you look at the base here, okay, that's e. And notice here we have natural log. Remember, the base for natural log is e. So if we took this e to the natural log of x squared, that is the same thing as e log base e x squared. So you can see that this base and this base are the same. Now, you're not going to rewrite natural log as log base e. When you see natural log, you just need to picture this. You need to picture that e right there. Okay, so just remember ln, when you have natural log, this ln, that's just like abbreviating this. Instead of writing log base e, you just write ln. And so that's where that is. And then this one's pretty easy to see. You can see the base here and the base here. The base on the log and the base on for the exponent, they're the same. So your answer is your exponent. Okay? All right. So let's look at some more properties. And what I'm going to do, I'm going to come back. Well, no, I tell you what, I'm not going to come back to it. Let's just go ahead and do it right now. I showed this in the previous video, but I'm going to show it in this video too about this property right here. So if you have, let's say you have the log of, say, 8 with base 2, and you want to evaluate this. Well, in order to evaluate this, this right here is just a quick review from the previous video, the video right before this one in the playlist. All right. So for this, I have a base of 2. See, that's the base of the log. But now I need this to be a 2. Well, I can rewrite 8 as 2 cubed, and that's base 2. Okay, so I just rewrote 8 as 2 cubed. So you see how this 2 and this 2, the bases are the same. So my answer is my exponent. And then let me do just one more. Let's do base 3 of, say, 1 over 9. All right, so I've got a base 3 on my log. So I want to see if I can rewrite 1/9 as 3 raised to a power. And so this is going to be log base 3. And then this is 1 over 3 squared. I just rewrote the 9 as 3 squared. But remember, I need to get 3 raised to a power. So if I take this 3 squared and move it up to the numerator here, then that's going to be the log of 3. And remember, when you move it across the fraction bar, it changes the sign of the exponent. And now you can see the base on my exponent, the base on the log are the same. So my answer is the exponent. Okay, so that's just a quick review. That's in the last video, but I just wanted to review it real quick. All right, so now we've got some logarithmic properties. So for m greater than 0 and n greater than 0, we've got the log of m times n is the log of m plus the log of n. And yes, it's base a. I'm just not saying base a, but that it goes for any base. So what this means is that if we have factors multiplied here, we can split it up using addition. And if we have division, see m over n, we can split that up using subtraction. And then for this one, all this one's telling us is that we can take this exponent, pull it down in front, and multiply it to the log. Okay, and n is any real number. Okay, for this one. And these properties, they can go back the other way. If it's addition, it can come together as multiplication. If it's subtraction, it can come together as division. And if we have a number down here, we can throw it back up into the exponent there. All right, so let's look at some examples. All right, so write each expression as a single logarithm, and all variables represent positive real numbers. So we want to bring these together. So this is equal to, I'm going to rewrite it as a single log, so that's log base 3. Now, this is addition. Addition comes together as multiplication, so that's x times 6. Okay, see, this times this. And so that's going to give me log of 6x with base 3, and that's my answer. Now look, this step that I showed right here, you don't have to show that step on this problem. This is just easy. You bring them together and multiply x times 6 is 6x. You could go straight to this step right here. All right, so what about this one? I've got natural log of 3 plus natural log x squared plus natural log y. They're all addition, so they're all going to come together as multiplication. And so this is going to be natural log of 3x squared y. Okay? And this is my answer. All right, next example. So let's look at this one. So this one is split up with subtraction, and I want to bring it together. Well, remember, subtraction comes together as division. All right, so this is going to be the log base 3 of 24 over 4, which that's the log of 6 with base 3. And there's your answer. Okay, see, subtraction comes together as division, 24 over 4. And what about this one? Well, this is going to be what? Natural log x to the 6th over x squared. Subtraction comes together as division. Don't worry, that the problem's going to get a little tougher. I'm doing some easy ones to get you, to get you to understand this stuff. All right, and so this is going to be natural log of x to the 4th, and there's your answer. Okay. All right, so that's when they're split apart using addition and subtraction. Remember, if it's split apart using addition, that comes together as multiplication. If it's split apart with subtraction, that comes together as division. Okay, and we're going to work some in a minute where there's addition and subtraction in there. They're a little more complicated. All right, so let's look at this. Rewrite each expression in terms of log 3. So what they want here is they just want log 3. They don't want anything else in the parentheses here, just log 3. So for this one, I need to get rid of this 8. Well, remember that property we just had, this one right here, that says we can take this exponent and move it down in front and multiply it. All right, so this is going to be 8 times log 3. Okay. All right, so what about this one? This is square root of 3. All right, so what am I going to do with that square root there? Well, we could write this as what? 3 to the 1/2, right? Remember, changing from radical form to exponential form. So the square root of 3 is the same thing as 3 to the 1/2. And now I can take this exponent and move it down in front. So that's going to be 1/2 log 3. And there's my answer. All right, so what about this one? Log of 1/3. Well, this is, remember, this is 3 to the 1st. So I can move this across the fraction bar. So that's going to be log 3. And when I move it across the fraction bar, it changes the sign of the exponent. So that's going to change from a positive 1 to a negative 1. And now I can bring the negative 1 in front, so that's negative log 3. And there's my answer. Okay. All right, moving right along. So here is all of your properties together. So rules of logarithms with base a. So if m, n, and a are positive real numbers with a not equal to 1 and x is any real number, then the log of a with base a is equal to 1. The log of 1 with base a. So no matter what the base is, if you're taking the log of 1, that's 0. Okay, and then this one, the log of a to the x with base a is x. If these are the same, your answer is your exponent. Now look, this one right here, this property here, you don't need to memorize that one, okay? Because if you know this, then you can get it. Because look, the bases are the same, right? The base of the exponent, the base of the log are the same, so your answer is your exponent. Well, look, the base of the log, the base here is the same. Isn't that understood to be a 1? So your answer is your exponent. And then we looked at this one earlier too, where it was in the log was in the exponent. This base and this base are the same, so this is your answer. And then we covered these also. And then this one is the log of 1 over n with base a is negative log of n with base a. And really, you don't even need to remember that one because, see, 1 over n, didn't we? See, we just did that here, 1 over n. Okay, that, I mean, if you know that formula, it'll save you from having to do this step. But I think it's good, you know, to know this in case you don't remember the formula. You know how to work it. All right, so how about this one? Let's rewrite each expression in terms of log 2 and log 3. All right. So here we've got log 6. Well, remember, I just want 2 and 3. Okay, so this is log of 6. Well, 6 is what? 2 times 3, right? And so this is multiplication. Okay, so I need to split it up using addition. Multiplication splits up using addition. Division splits up using subtraction. So that's going to be log 2 plus log 3. Okay, and there's your answer. All right, now what about this one? Well, this one's division, and I need 2 and 3. All right, well, I've got a 3 here, but here I've got 16. But what I can do is that 16, I can rewrite 16 as 2 to the 4th. You see that? And so this is going to be what? Log 2 to the 4th. Now this is division, so that splits up using subtraction. And that's log 3. All right. Well, we still have a problem. We've got this 4 right here. So I need to take the 4, move it down in front. So that's going to be 4 log 2 minus log 3. And there's your answer. All right. All right, so now we're getting into some that are a little more complicated. All right. Now, I'm gonna work this one out an easy way, and then I'm gonna do it again with showing a lot more steps. Okay, to show you how to show you how it works, how I'm doing it the easy way. All right, so this is going to be natural log. All right, so remember, well, this is the easy way to remember it. If it's multiplied across the numerator, that's going to be split up with addition. Whatever's being multiplied across the denominator is going to have a minus sign in front of it. So everything multiplied across the numerator is going to have an addition sign. Everything multiplied across the denominator is going to have a minus sign. So that's natural log 3 plus natural log x squared. See, it's multiplied across the numerator. Now the y is in the denominator, so that's minus natural log y. The z is in the denominator, minus natural log z. And then I need to take the 2 and move it down in front. When they want you to express using sum or differences, or they want you to expand, you might see the direction say expand the logarithm. They don't want any exponents in here. So this is going to be natural log 3 plus 2 natural log x minus natural log y minus natural log z. And this is your answer. Now, what a lot of students ask me when I do this is, shouldn't this one right here, the sign in front of natural log z, shouldn't that have a plus sign in front of it because it's multiplication here? Okay, so let me show you. So natural log, let's look at it again, 3x squared over yz equals. Now, if I just look at the numerator, look at the denominator, that's natural log 3x squared minus natural log yz. Okay, so that's just split up using subtraction. And then this would be what? Natural log 3 plus natural log x squared minus, this is multiplication, so that's natural log y plus natural log z. But remember, it's minus this whole thing, so this has to be in parentheses here. And then you can see what happens. That's natural log 3. I'm going to go ahead and bring the 2 down, 2 natural log x, and then I distribute the minus natural log y minus natural log z. And you can see I get the same answer. It's just, see, this right here is more work. It's correct to do this, and that's showing all the details in every step, and that's fine. But look, it's just easier to remember. If it's multiplying across the numerator, it's going to have a plus sign in front of it. If it's going across the denominator, it's going to have a minus sign in front of it. That's the easiest way to remember it. Okay? All right, so let's take a look at this one. All right, so this is going to be what? This is going to be log base 3 of x minus 1 squared, right? See, that's what's in the numerator, minus, and that's going to be log base 3 z to the 3/2. All right. Now, let's move the exponents in front. So that's going to be 2 log base 3 x minus 1 minus 3/2 log base 3 of z. Okay, and this is your answer. Now, one thing I want to mention, let's just look at this log x minus 1. This is not equal. This sign right here means not equal to log x minus log 1. You cannot do this. This right here is no, it is bad. Okay, you cannot do that. All right, now let's rewrite as a single log. Okay, so we want to bring this together as a single logarithm. So remember, addition comes together as multiplication, subtraction comes together as division. The easy way to remember it, like I explained earlier, if it has a plus sign in front of it, it's going to be multiplied across the numerator. If it has a minus sign in front of it, it's going to be multiplied across the denominator. Okay. All right. So the first thing we need to do before we can start bringing it together is this 3 has to get out of the way. So we're going to take this 3 and throw it back into the exponent. So that's going to be natural log x minus 1 plus natural log 3 minus natural log x cubed. All right, so I just threw the 3 back into the exponent. And so this is going to be natural log, and this is going to be 3 times x minus 1, 3 times x minus 1 over x cubed. And then if you want to, I mean, it's fine if you leave it like that. I guess depending on who your teacher is, if you're my student, you can leave it like that. But you can also distribute the 3. This or this, I think, should be fine for most teachers anyway. All right, so what about this one? All right, first, let's throw the exponents. Let's throw these numbers back into the exponents. So that's going to be log y to the 1/2 minus log x to the 1/3. Now subtraction comes together as division. And so that's going to be log y to the 1/2 over x to the 1/3. All right. And then what you want to do, the way that you're going to see the answers mostly in the books and the textbooks and stuff is like this: the log of square root of y over the cube root of x. They'll go ahead and take these exponents right here and convert them back to radical form, and there's your answer. All right, so that's bringing it together. Okay, all right. So what I want to do before I go on to the next stuff is I just want you to see this. Let's say we have natural log x plus natural log y minus natural log z plus natural log w minus natural log a minus natural log c. And we want to bring that together into one logarithm. Okay, I think after working this problem, it's all going to make sense to you. So this is going to be natural log. Now remember what I said. If it has a plus sign in front of it, it's going to be multiplied across the numerator. If it has a minus sign in front of it, it's going to be multiplied across the denominator. So this is going to be x, see it has a plus, y, minus sign, so that's z, plus sign, so that's up here, minus sign, so that's a, minus sign, so the c goes down here. And this would be your answer. And that's all it is to it. Okay, that's all it is. Don't make it harder than what it is. All right, so let's see about this. Find an approximate rational solution to 1.03x. 1.03 raised to the x equal 5. Round to 4 decimal places. All right, so how are we going to go about working this problem? What do we do? All right, so this is going to be 1.03 to the x equals 5. All right, so if you remember back when we covered the solving exponential equations, that's what this is, an exponential equation, the variables and the exponent. All right, so to solve this, well, we wanted to get the basis the same, but you're not going to get the basis the same here. Okay, so the way that we're going to do this is we're going to take the natural log of both sides. Okay, now I took the natural log of both sides. If you wanted to, you could do this. You could take the log of both sides. It doesn't matter. Okay, it doesn't matter. You're going to get the same answer either way. And you could also take the log base 3 of 1.03x equals the log base 3 of 5. You could do that too, but why would you do that? Okay, because we don't know, we can't evaluate log base 3, log base 5, log base 7 with numbers like this. Okay, I mean, we can, but it's a lot more difficult. Why do we use log? And remember, when there's not a base, what is that base understood to be? It's understood to be base 10, right? All right. So why do we use log base 10? Why do we use natural log? Why are we using those? Because those are the buttons on your calculator. Okay. All right. Now, natural log, log, ln, log, it doesn't matter which one. I always use natural log. Okay. That's what I use. I use natural log. Why? I don't know. I guess because for, I guess instead of writing 3 letters, I only have to write 2, being lazy. There you go. So now we need to know what x is. So let's take the x. Let's use that property that says we can pull this exponent down in front. So that's x natural log 1.03 equals natural log 5. And then I can divide both sides by natural log of 1.03. And so my answer is x equals the natural log of 5 over the natural log of 1.03. And then if we punch that into our calculator, we get 54.4487. Okay? And look, this right here is an approximate answer. And this one, this right here, is an exact answer. So you may see in the directions when you're doing your homework, if it's in the book or whether you're using My Math Lab or whatever you're using, the directions say find the exact answer. If it says that, then you leave it like this. If it says give an approximate answer round to 4 decimal places, then you're going to do this. Okay? And it may ask for both, but now you know what they are. All right, so let's look at this base change formula. And we don't have too many left. This video's going shorter than what I thought. Anyway, all right, here we go. So base change formula. So if A is positive, B is positive, and neither one of them's equal to 1, and M is positive, then the log of M with base A equals the log of M with base B over the log of A with base B. Okay, so when does this base change formula, when does it come in handy? Well, if you have something like log 5, or if you have something like natural log 2, something like that, you don't need the base change formula because you've got a log button and you've got a natural log button on your calculator. Just punch it in, gives you an answer. Or if you have something like this, the log of 16 with base 4, well, that's the log of 4 squared with base 4, which equals 2. That's that property. The base of the log, the base of the exponent are the same, so your answer is your exponent. Okay, you don't need the base change formula. Well, what if we have this, the log of 7 with base 3? Okay, well, can we rewrite 7 as 3 raised to a power? Well, you can, but it would take you forever to figure out what the exponent needs to be. Okay, so the methods that we've learned so far, no good. We don't know how to do that. That's where this base change formula is going to come in. So you see what it says, the log of M with base A. Here's M, here's A. M is 7, A is 3. So this is, now just bear with me a minute, natural log of 7 over natural log 3. And that's all it is. Okay, now you might be wondering, well, they got log base B here. And that's right. You can use any base you want. What did I choose to do? I said, okay, I want B to be log base E, right? 7, 3. You see that? Well, what's log base E? Natural log. Okay, I just chose to do natural log, and that's what I do. If I do the base change formula for this, I'd use natural log every time. Okay, I don't know why, I just do. Okay, it's just, to me, it's easier to write ln than it is whatever. Okay, and look, if you did this log 7 over log 3, you'll get the same answer. Same answer. You can try it. Punch this in your calculator, punch this in your calculator, and you'll see that you get the same answer. But if you try it out now, pause the video so you don't miss anything else. All right, so let's look at this. So we've got our favorite, everybody's favorite here, word problem. So if $2,500 is invested at 6% compounded daily, then how long would it take for the investment to double in value? Okay. All right, we've got compound interest here. So let's write down the compound interest formula. You may remember it from previous videos. A equals P times 1 plus R over N raised to the NT. All right. Now, what are we wanting to know? How long would it take? Okay, so how long would it take? That's T. Remember, that's what T represents, the number of years. Okay. All right. So now we've got to plug in for everything else. So let's see. Well, we've got P. Let me write this in a different color. So we've got P is 2,500. That's the amount invested. We've got R is 6%, so that's 0.06 in decimal. Okay. And we've got N is, that's the compounding period. Well, this is compounded daily, so that's 365. Okay. So if you remember from previous videos, remember if it's compounded monthly, N would be 12. Compounded semi-annually, N would be 2. Compounded quarterly, N would be 4. And compounded annually, N would be 1. Okay. And now, so I've got something to plug in for P, R, and N, and I'm solving for T, so I need to know what A is. Well, in this problem, A is what? 5,000. Well, it doesn't tell me that it's 5,000, does it? But how do I know it's 5,000? Well, you invest 2,500. How long would it take for the investment to double? So what do we get if we double 2,500? 5,000. All right. So plug everything in. So that's going to be 5,000 equals 2,500 times 1 plus 0.06 over 365 raised to the 365t. All right. All right. So that's not bad. Okay. So we're just replacing each of the letters with the numbers. And now I need to solve. So I need to solve for t. So first thing I'm going to do is I'm going to divide everything by 2,500. So I get 2 equals. All right, so now I'm going to punch this into calculate. Well, I'll tell you what, let's not do that just yet. 1 plus 0.06 over 365 to the 365 t. And so I get 2 equals. Now, when you push this into your calculator, you get 1.000164384. And that is raised to the 365t. All right. Now, how do we solve this? What do we do? Well, isn't that... Well, where is it? Didn't I just work one? Yeah, isn't that just like this? the variable's in the exponent, I'm not going to get my basis the same. So what do? I'm going to take the natural log of both sides. All right, so take the natural log of both sides. So that's going to be the natural log of 2 equals the natural log of 1.000164384 to the 365t. And now what? The 365t, let's bring that down in front. So that's going to be natural log 2 equals 365t times natural log of 1.000164384. And then I need to get t by itself, so I'm going to divide both sides by 365 natural log of that number. And so that is going to give me t is equal to natural log 2 over 365 times natural log 1.000164384. Okay, so yeah, I just divided both sides by 365 natural log. And so they cancel out over here and they'll be in the denominator over here. And so that's going to give me t is equal to 11.553 years. That's how long it would take the $2,500 investment to double. You'd have to wait about 11 and a half years. All right, so what about this one? And I think this, yes, look at that. This is the last problem. Now, this video is a lot shorter than I thought it would be. All right, so for what annual percentage rate would $1,000 grow to $3,500 in 20 years compounded monthly? All right, let's write our formula down again. So I've got A equals P times 1 plus R over N raised to the NT. All right. Now, what do we do here? All right, well, first, let's decide what we're finding. So what does it ask us? For what annual percentage rate? For what annual percentage rate? So I'm looking for R. You see that? I'm looking for R. So we need to know what A, P, N, and T are. So we have got, let's see, A is, well, let's see, find for what annual percentage rate would 1,000 grow to 3,500. So that's what we want to have. We want to have the 3,500 in the future. So that would be the 3,500. We've got P is, that would be our 1,000. What else do we have? We got 20 years, so T equals 20, and compounded monthly, so N is 12. All right, so let's plug everything in. So I got 3,500 equals 1,000 times 1 plus, now I don't know what R is, that's what I'm looking for, that's 12, raised to the, what, 20, or well, I guess we'll write it in order, 12 times 20, it doesn't matter if you put 20 times 12, same thing. All right, so let's divide both sides by 1,000, okay? So that's going to give me 3.5 equals 1 plus R over 12 raised to the 240. 12 times 20, that would be 240. Now, how in the world do we do this? Okay, how do we do this? Well, look at it this way. If I had x cubed equals, say, 20, then x is what? The cube root of 20, right? We take the cube root of both sides. Or if it's x to the 5th, this would be the 5th root of both sides. You see that? Now, also remember that this is the same thing as 20 raised to the 1/5, right? Raised to the 1/5. You see that? If I write my radical as a exponential, remember going from radical form to exponential form. Or if this was a 7, this denominator would be 7. If this was 240, that denominator would be 240. Okay. Oh, but look here, we got 240 right here, don't we? So this is what? This is 1 plus r over 12 equals 3.5 raised to the 1 over 240. Okay. You see that? Now, what do? Well, we got to get r by itself. So now we're going to subtract 1 to both sides. So that's going to be 3.5. Whoop. Almost left the exponent off. Minus 1 equals r over 12. See that? All right. So now we got to get rid of the 12. So we're going to multiply everything by 12. And so that is going to give me 12 times 3.5 to the 1 over 240 minus 1 equals r. All right. And then if we punch all of that into our calculator, we get r is equal to 0.063, or we can say r is 6.3%. If we change the decimal to a percent. Okay. So I hope that video made sense, and like I said a couple times in the video, it's going to be shorter than what I thought it was. I thought this would be a lot longer video, but it's good for you. Don't have as much to watch, don't have to listen to me that much, but hopefully the video helped. Check out my other videos, give me a like, share, and subscribe, and thanks for watching.